testing. One ample, take one.
Charlotte, the whole analyzer system at first glance looks like a mess of wires and tubing. But what it is a central analyzer connected to 8 different chambers. And because that central analyzer is connected by tubing to these 8 different chambers, it kind of looks like a spider, which is where she gets her name, Charlotte. The way the whole system works is we have these chambers that look like an upside down bowl. That bowl is placed right on the soil surface. And when it's placed on the soil surface, then we have this enclosed environment where we can measure how gas is being exchanged between the soil and the air right above it. And we measure the change in concentration of carbon dioxide in that small area over a period of 2 minutes. Even though we're measuring from all these different locations, everything's analyzed right here. The gas is just moved through this tubing, so to measure from one car at a time. There's a space between each chamber measurement because we have to wait for the gas from the previous measurement to be all flushed out of the line and then start bringing in the new gas. They're in their sort of waiting period right now, so about 5 seconds, chamber 4 will go. Yeah, so then in about a minute, the other one will go. And that change is what gives us our flux data. So that change is a flux of carbon dioxide. And that could be a flux of carbon dioxide from the soil environment to the atmosphere, or it could be from the atmosphere to the soil via the plants.
A large percentage of the Earth's carbon is actually stored below ground in Arctic soils. And with increased warming, it's hypothesized that a lot more CO2 will be released into the atmosphere. And so these Arctic and subarctic ecosystems are real important stores of below ground carbon, and changes in flooding and changes in off-gassing and as well as the vegetation above ground could really affect global CO2 concentrations.
So our 8 different chambers are on 8 different study plots that are looking at an early grazing treatment, a typical timing of grazing treatment, late grazing, and no grazing, and each of those with an advanced growing season and an ambient growing season. The biggest part about setting up Charlotte is setting up the power supply. It requires a lot of energy to run that system because it's running 24 hours a day, and it includes automated moving parts in addition to the analyzer that analyzes gas concentration. When we first were setting up Charlotte this year, we got everything all set up. We have all of the chambers situated in the study plots. Everything's ready to go. And we go to turn it on and nothing happens. So we go back through and we're checking all the wire connections, like what's happening here, what's happening. Turn it on, nothing. We'd spent several hours that afternoon troubleshooting and looking at things, and finally okay, we're just gonna go in, have some dinner and tackle it later. So we were just sitting down to dinner. Somebody makes a comment about how did it go trying to set up Charlotte? We're like, oh, we're not getting power to the system. And then Josh just looks up from dinner he was eating. He's like, did we turn on the multiplexer? And the multiplexer is the part of the instrument that pulls in the gas from one chamber at a time to the analyzer. And we're like, no, we did not. So we solved that problem just in the middle of dinner, like, that's what it is, and went back out and turned it on. Everything worked great.